Sections 6.3 and 6.4 of your textbook cover the topic of adding and subtracting rational expressions. As with multiplication and division, we can use the processes for addition and subtraction of rational numbers as models to follow when performing these operations on rational expressions. So to add or subtract two rational expressions having like denominators, we simply add or subtract the numerators and keep the same denominator. Let's look at some examples. In problem number 1, we're adding two rational expressions, both with denominator x squared minus 4. So we can add the numerators. X minus 7 plus 9 is x plus 2. And then we keep the same denominator, x squared minus 4. To simplify our answer, we can factor the denominator. Remove the common binomial factor of x plus 2 from the numerator and denominator, and obtain the answer 1 over x minus 2. The restrictions on the problem are that x cannot equal positive and negative 2. Let's look at a second example. In this case, we're subtracting two rational expressions, each having the denominator x minus 3. Note that when we subtract this second rational expression, we're subtracting the binomial x plus 6. So we need to subtract each term of that binomial. So our numerator becomes x squared minus x minus 6. To simplify, we factor that trinomial. Remove the common factor, x minus 3, and obtain the answer x plus 2 under the restriction that x is not equal to 3. Now let's consider problems involving unlike denominators. First, we will identify the least common denominator of the expressions to be added and subtracted. Then rewrite the problem using equivalent expressions with that LCD. And finally, add or subtract and simplify the answers. Example number 1, the denominators are 3n squared and 9n. So the lowest common denominator is 9n squared. To rewrite these rational expressions as equivalent expressions using that denominator, we need to multiply the first expression by 3 over 3, and the second expression by n over n. Performing the multiplication, we have 3n minus 21 over 9n squared plus 4n squared plus 5n over 9n squared. Adding the numerators and combining like terms, we have 4n squared plus 8n minus 21 over 9n squared. This answer cannot be simplified. There are no common factors. So we simply note the restriction, which is that n cannot equal 0. Let's move to problem 2. In this case, the denominators are x and x plus 6. That means the LCD of these expressions is the product of x and the binomial x plus 6. So we'll multiply the first rational expression by the quantity x plus 6 over the quantity x plus 6. And we'll multiply the second rational expression by x over x. Multiplying the two binomials, x plus 6 and 2x plus 1, yields the trinomial 2x squared plus 13x plus 6. And multiplying x by the binomial x minus 8 yields x squared minus 8x. Now note that we are subtracting that binomial x squared minus 8x, so we can add the opposite of that binomial. And then combining like terms, we have 2x squared minus x squared, so we get x squared, 13x plus 8x, 21x, and then plus 6 for the numerator, and our denominator is x times the quantity x plus 6. Once again, no common factors, so we simply state our answer and note the restrictions. X cannot equal 0 or negative 6. Let's look at two final examples, slightly more complex. In the first one, we were subtracting rational expressions with two trinomials in the denominator. It would be helpful to identify the LCD if we had those polynomials written in factored form. So we'll rewrite the problem by factoring those polynomials in the denominator. Note that there's a common binomial factor in those denominators, x plus 2. So the LCD in this case will be the product of three binomials, x plus 3, x plus 2, and x plus 1. In the first expression, we need to multiply by the binomial x plus 1 over x plus 1. In the second expression, we need to multiply by the binomial x plus 3 over the binomial x plus 3. Performing the multiplication and simplifying as we go, we have x squared plus x. Note that we have negative 2 times x for negative 2x, and negative 2 times 3 for negative 6, all over our LCD. Combining the like terms in the numerator, and then factoring the numerator, and finally simplifying the common factor of x plus 2, we arrive at our answer, the quantity x minus 3 over the quantity x plus 3 times the quantity x plus 1. In this case, there are three restrictions based on the values of x that would make denominator equal to 0. Those three restrictions are that x cannot equal negative 1, negative 2, and negative 3. Now we'll look at one final example. X over x squared minus 16 plus 3 over 4 minus x. Again, it would be helpful to have the denominator of that first rational expression in factored form. And then noting that we have a binomial x minus 4 in the denominator, it would be helpful to multiply the numerator and denominator of the second rational expression by negative 1, so that we can obtain the opposite of 4 minus x, which is x minus 4, in the denominator of our second rational expression. This means that our LCD is simply the product of x plus 4 and x minus 4. And our second rational expression should be multiplied by the quantity x plus 4 over the quantity x plus 4. Performing the multiplication, we have x minus 3x minus 12 over our LCD. Combining like terms in the numerator. And then factoring the numerator, we can see that there are no common factors. So we have our answer in simplified form, and we can state the restrictions. X cannot equal positive and negative 4.